Welcome to the Hidden Why Podcast, episode 2019. My interview with Brendan Borrell. We're discussing his new book, The First Shots. I hope you enjoy. Hi, Brendan. Welcome to the Hidden Why Podcast. Great to have you here today.
Hey, Lee. I'm very happy to be here.
Probably getting a bit cooler over there in Los Angeles at the moment.
Just got a good rain today. I'm wearing a jacket in my house, so yes, it's cooling off.
Yeah, we got the opposite here, of course. We have very humid weather today, potentially storms coming through again as well. So opposite side of the spectrum.
Gotcha, yeah.
So, mate, tell us a bit about yourself. Well, you've got a new book out, which we're going to delve into, and the book is called The First Shots, The Epic Rivalries and Heroic Science Behind the Race to the Coronavirus Vaccine. Probably a very sensitive topic at the moment on all accounts. But before we jump into that, what's your background? Tell us a bit about what you've done more recently.
Well, I've been a freelance journalist for about 15 years now, writing for different magazines, newspapers, websites, everything from like The Atlantic, Audubon magazine, which covers birds of all things, to like places like Businessweek. And The First Shots is my first book. I came to writing from I got a PhD in biology. Actually, I studied bees in the tropics of Central America, and got really deep into entomology before saying, you know what, I love writing. I'm going to change course here.
All right.
And that was in 2006, and so I've never looked back.
So what is this, your first book, did you say, or you've got other books?
It's my first book, yeah.
Is it? I thought you had other books there. I don't know why I thought that. There you go.
My name is on a textbook. So sometimes people see that textbook and they say, oh,
maybe that's,
but yeah.
Okay. The First Shots. It's on Amazon. We'll stick the links in the show notes so everyone can grab a copy and have a read as well. But such a, what made you get into, like, from bees and birds to writing about the vaccination?
Well, yeah, once I started, down the path to becoming a journalist, I did kind of focus some of my early writing on the scientific world. And, I loved writing about people and their passions and people who are just really good at what they do. And gradually I kind of broadened out and became kind of a generalist journalist. And I'd write about everything from like crime to the environment, and sometimes even straight business stories. But when the coronavirus broke out in January 2020, it kind of threw my life, like probably yours as well, into a bit of disarray. I mean, as the months rolled on and we saw that this was going to be a global pandemic, and as somebody who's specializes in science, I thought, how do I contribute to this? How do I use my expertise to write about this topic? And I started reaching out to some of my sources, and it was becoming clear that the vaccine story was going to be the big story. We were not going to get out of this pandemic until we had a vaccine.
And is that still your belief?
Yeah, that is my belief. I mean, the vaccine, has absolutely, it's cut down on the severity of infection and hospitalizations. And it's been a remarkable historic scientific achievement.
Yeah. This whole, congratulations on the book, first of all, and for putting your time and energy into such a book, because I think it's really important. And I don't think there's enough discussions going on about the vaccines and the science behind the vaccines. It seems to become more of a political issue and a race for, now in Australia anyway, at least, mandates and forcing people into maybe things that they don't want to do, i.e. get a vaccination. And that's becoming a bit of a political issue here in Australia. I don't know, is that the same over there, or is it still divided?
I mean, absolutely. Here in Los Angeles, we're facing a showdown over the vaccines for kids in school in our school district here. And basically the school district set a deadline, and if kids aren't vaccinated by January 10th, then they will have to be homeschooled. or
Is
have
that
an independent study.
5 to 11 year olds, or five, or basically all school children above 5?
I think it's 12 and up, is my understanding. Yeah.
12 and up.
So
Because
yeah,
I
and
know
I mean
they've
that.
just released, or just about to release, a safe or a lower dosed vaccination for kids between 5 and 11.
Mhm.
Have you?
Yeah. I don't think that the rules here apply to that yet. But yeah, I mean, I think the mandates have been a hot button issue, and I think part of my book, my book tracks the vaccine as kind of a scientific accomplishment and places it in the political and social context as well, because that is so important. I mean, I actually was in Australia a few years ago. You guys have this virus there called the Hendra virus, which spreads from bats to horses, and it has kind of a fatality rate close to like Ebola. And there were a number of people who, the scientists developed a vaccine that you could give to horses to basically stop the chain of transmission. But there was a group of people who were unwilling to do that. They were fearful of doing that to their horses. And I wrote about anti-vaxxers in that realm. And it kind of prepared me for what's been happening now with the COVID story, which is a very different story, but fascinating all the same.
Yeah, and I mean, I don't know enough about the Hendra, but I've heard two sides to the story, and some people who have said that when the vaccine for the Hendra came out, a lot of horses died from the vaccine.
Yeah, I mean, when I worked on that story, I dug into it. It just there wasn't really evidence that that was the case. I mean, I think I talked to people who felt that was the case. They said, "Oh yeah, within a week." But there was, yeah, I mean, this vaccine, that Hendra vaccine, has been pretty safe. So I don't know about that.
Yeah. So how do you? And this is a big part of the issue, I guess, because there's so many people that I speak to that are for the vaccine, obviously, but there's an equal amount that I speak to that are certainly not for it, and they're not against it, but perhaps they're just like, why should I get something that's been only trialed for a very short time? And I guess people have questions about the trials and things like that too. And also, for healthy people, because it seems like in Australia anyway, it's a 0.007% chance of dying from coronavirus. And usually it's the vulnerable people, the elderly, and those that already have underlying illnesses. So there's a lot of skepticism about the need for taking a vaccine. And I assume that's the same case over in the United States. But what are your thoughts on that?
Yeah, I mean, that's absolutely right. I mean, what we've seen with the COVID is it mostly affects the elderly, the vulnerable, people who are immune compromised. I'm a healthy person in my 40s. And my risk of dying or being hospitalized for COVID is very, very low. In fact, I had a positive COVID test even before I got the vaccine, and was basically asymptomatic. And so I think that definitely a person's sort of risk reward equation is a little bit different with vaccines. I mean, so I mean, the challenge with a vaccine, as opposed to a drug, like a coronavirus drug, is that a vaccine is given to healthy people. So you're giving it to millions of people. So even millions of healthy people. So even a very rare side effect would be a problem, would be a reason why somebody might not want to take the vaccine. I mean, at this stage, these vaccines, however, have been tested extensively. The side effects we've seen have been incredibly rare. There's been, with the mRNA vaccine, particularly the Moderna vaccine, this sort of heart inflammation, myocarditis in some young men, mostly not super serious. And the vaccines have been rolled out to, billions of people at this stage. Yeah. So, I mean, they are really safe. And so, so I don't think the argument that it's unsafe is very convincing. The question is, well, why would you do it if there's a low risk? Well, number one, there is a low risk that you're going to get hospitalized, but there are still people in my age group that have had serious COVID, even though, they are in that 0.7% or whatever the number is. I'm actually not sure exactly what it is. But and so you are going to have a risk of developing that. And so, at least in the US, we get vaccines for free. It's it gives you super immunity. It's great. I'm a person who I've traveled the world. I love going to remote regions, and I collect vaccines like, like nobody's business. I like being able to be like, not worry if a mosquito bites me and I'm going to get malaria. I like, yeah.
Yeah.
And so I don't
But I think
really.
there'd be a lot of people out there that would say, I'm not actually worried about getting coronavirus because I don't think it's going to affect me that much. And yes, if I'm on that rare spectrum of being affected by it as a healthy person, then so be it. But and there's probably an equal amount of people that are talking to people that have had adverse side effects that maybe aren't being reported that well.
I mean, I think at this stage, I've the data has come in, and these things, the side effects are still incredibly rare. We have the Johnson and Johnson vaccine, which has had a little bit of a clotting disorder in young women, and then the myocarditis in the mRNA vaccines, and neither of these are a big deal.
Do you feel that it's being reported well, the side effects that are, from people having a vaccine and going to hospital for whatever side effects they've had? Do you think that's being reported?
Well, what I can speak to is here in the States, we have a vaccine adverse event reporting system. And anytime there's an adverse event, something like that, it gets put into a database, it gets investigated and sort of determined whether it's likely to have been caused by the vaccine or not. And so,
is there a link of that data that people can go to and grab it and read of all the reported cases? Is that public information?
That is public information. I think that database in particular has been misused by some people because these are, it's the difference between an alleged suspect and somebody who's been convicted of a crime, right? It's like you said, people who got, their horses vaccinated and then a week later their horse died, they blamed it on the vaccine. It's the same situation. Correlation is not causation. So yes, I think, the surveillance efforts have been pretty good. And we haven't, the thing is, Lee, that, there are vaccines historically that have caused problems that we have discovered. And that, some vaccines that even, were pulled from the market. I mean, one of the classic cases, something that I wrote about in the book, was the first polio vaccine developed by Jonas Salk. I mean, this was supposed to be a killed virus vaccine, but the technique that he used to kill the virus on a small scale, when sort of manufacturers started to replicate it on a large scale, it wasn't 100% effective. So some people ended up getting polio from the vaccine. And it was an incredible tragedy. And that led to, another layer of scrutiny and the development of the modern Food and Drug Administration's, vaccine regulatory efforts these days. And so, I would not argue that there are not situations where there are problems with vaccines, and we've learned from that experience. That was 50 years ago. And so I think, the claim that these vaccines are somehow dangerous, I don't think so. I mean, the risks of these are much lower than drugs that you and I take pretty regularly for other conditions. I mean, I think one of
I don't take drugs, Brendan.
You don't take
my game. No,
well,
I do a lot of stupid things, but
sure. Well, I mean, one of the comparisons that was made was with with Johnson and Johnson's vaccine. This, the rate at which this clotting disorder was turning up was less than the risk of blood clots from birth control. And it's kind of like, this is something that many people take without even thinking about it. And why are the vaccines sort of held at a different level? And I think I want to make a second point here, which is because I'm actually very sympathetic to people who are young and healthy and are like, what, I don't even, for them, it's just like, I don't want to go sit and wait in line and even get a vaccine or be like, have a fever for the next day and just deal with the inconvenience of it. But I mean, in the middle of a pandemic, you're also doing something for your community and for people who are, at greater risk than you are by reducing the transmission. We know that these things don't eliminate transmission completely, but they cut it by about, with these variants, which has been a problem. There's, with the Delta variant, they still cut it by transmission by about 1/5. So that is a benefit. And then it also keeps the emergency rooms from filling up with the rare people, because it doesn't take that much to overwhelm our hospital systems. So I'm supportive of people getting the vaccines in general.
Yeah, I'm not in general, and I'll play the devil's advocate here. And
Sure.
I guess it's a thing of trust, isn't it? I mean, nowadays we have so much information at hand, whereas 20 years ago, perhaps all we had was a newspaper, maybe a radio, and maybe a TV with a limited amount of news. And for those who watched it and listened, was probably a lot less. But now we've got social media streams, we've got real news, fake news, you name it, anything in between. And I guess a lot of people probably don't do the efforts of going into the science and the research like you have done for this book. So they just rely on this information. And whether you're pro or not, I guess you have a biased tendency to what you believe, and maybe you focus on that. But I think there's a big level of trust, and certainly from my perspective here in Australia, is that if you look around, how do we gain trust that a vaccination that doesn't seem to stop the spread, because as you said, it still is spreadable for those who are vaccinated. It doesn't seem to be stopping the people that are vaccinated from getting COVID. There's also a big medical push and forced mandates to force people to get vaccinations. And that raises a big question mark for me. Like, why would you force something on people for their own health reasons, yet still sell tobacco at our stores, which makes obviously the government a lot of money here in Australia? So there's all these questions around, that would give people a lot of skepticism. We've had, I don't know, it's 6,000 or 8,000 medical workers here, I believe in Queensland only, that have chosen not to get the vaccination and been forced to step down or not work for that reason. And that sort of, I guess, would, for a lot of people go, well, why are the medical professionals not even getting it or not wanting to get it? So there's a lot of trust issues with what's going on. And it's not to say that the science behind the vaccinations aren't there, but it's more about a trust thing.
I mean, what do you mean it's more about a trust thing? I mean,
well, you don't trust it, do you? If you have all this conflicting information. So we can go out, for example, here in Australia. We could go to the supermarket, unvaccinated, to buy groceries.
Mm-hmm.
Now you can't go to a restaurant unvaccinated to have dinner.
Mm-hmm.
So there's conflicting ideals here that I guess confuse the population. And this is what I'm saying. It's
right.
not whether it's right or wrong.
I think that's a good point. I think we got, the word for that we call that pandemic theater. Because of some of the, less scientific, lack of consistency, in some of the policies at different state and local and federal levels. And I think that absolutely has been confusing to people, that you can go to a restaurant and you can take off a mask, whereas in other contexts you can't, as though the virus is going to respect that. And I think there are even curfews in some places. And some of that stuff was pretty silly. Absolutely.
Still is still going and getting worse.
Some places, I think it's a different story in different places. I mean, here in
I'm just talking from our perspective in Australia, and I think we've had some of the harshest penalties, lockdowns, etc. in the world. We've certainly had the longest period of lockdowns here, and we've probably got some of the strictest mandates coming into play as well.
Right. Yeah. And I mean, that's been really tough for people. I mean, that was, I had heard about that. And I mean, the pandemic has wreaked a lot of economic havoc. The question is,
well, it's not even the economic havoc, but you've got to look at it from the health perspective too, because what they're saying is that they're forcing these mandates and forcing people to get vaccinations because they're concerned about the greater public health. Now, if that's the case, then let's go back to why we're still selling tobacco at stores. And what about all the other health issues that probably aren't being, noticed or talked about enough? But I'm sure there's a lot of, people going out of work, maybe suicide rates, mental health issues, that must have been increased over the last couple of years with this pandemic. I couldn't imagine why it wouldn't, because there's a lot of stress in people's lives at the moment.
Sure. I mean, I think, Lee, you got to draw a difference between going out and smoking and doing something that's going to affect other people's health around you. I mean, a transmissible disease is you're impacting your community. It's a societal burden that you have a responsibility to other people to reduce that. And that's kind of, whether or not a complete lockdown, how draconian the measures should be is, that's fair to argue,
debate, isn't it? Yeah.
Yeah. I mean, and I just want to be clear, like, I'm not a public health person. I'm a writer, and I'm fascinated by this stuff. But I can't talk to you in detail about the pros and cons of lockdowns in different situations. I think that there are some interesting sort of philosophical questions to engage in about, the value of a human life, and whether, I mean, do you believe that an elderly person's life is worth less than a younger person's life? I don't know. How do you feel about that?
Yeah, I don't know. I sort of, and this might sound a bit vicious, but I think a lot of people have had the same thoughts. I thought when the coronavirus came out, here in Australia at least, that we should have let it just run its course. And I know that sounds terrible, but I think that would have been a better way for the population to build up some natural immunity to the coronavirus.
I think that there was just too much. I mean, that's like playing Russian roulette. There's too much scientific uncertainty. And there's uncertainty about the way that immunity develops. There was a strong belief at the time, and there's now evidence that vaccination provides you with stronger immunity than natural infection, number one. And number two, it does not come with the risks of actually getting COVID, because a certain percentage of people do get hospitalized or die. That's a fact. I mean, the numbers are pretty bad for the elderly. So I think you have that question of, I mean, people have proposed all kinds of things about, oh, well, what if we just had the lockdowns for the elderly, or you just isolate the elderly but take everybody over the age of 60 and put them on an island somewhere like you do.
Oh, look, and I don't disagree with that either, but it's and I'm glad I'm not the one making these decisions, because I think it'd be very hard to make these decisions. But I still would argue that, a vaccine for someone, at their choice it's different. It shouldn't be the same for everyone. Like an elderly person should probably get a vaccine, whereas a younger person should probably have a choice whether they get it or not. And the debate, I guess, on protecting the public, you make a good point. Like, that's a hard one to argue against as well, because you don't want to be, seen as selfish by not getting a vaccination and then spreading the coronavirus through the public. But then, people with the vaccine could potentially spread it. And actually, it's just happened here in Australia, where someone with the new variant, Omicron, has spread it to a population in North, so it's a tough one. But maybe we should talk about the science behind the mRNA vaccines, because you've done a fair bit of research, and that's what's included in your book as well. Can you tell us a bit about the creation of these and the race for the creation of these?
Sure. I mean, I think one of the things I sort of describe in the book is the fact that, the race, what allowed us to develop these vaccines in such record time was, of course, all of the scientific developments that have taken, over the course of 2 decades. I mean, first off, the mRNA technology, which had been kind of the dream to revolutionize medicine, because it is so much easier to manufacture mRNA compared to these complicated protein drugs and protein-based vaccines, had been something that folks had wanted to develop for a very long time. And they kind of were on the cusp of success when the coronavirus outbreak happened. And then the other thing was the fact that there had been, this small cohort of scientists who had been interested in coronaviruses and interested in developing vaccines against them. I mean, many of these emerging infectious diseases were not things that pharmaceutical companies, cared about. These were not thought to be money makers. Most of the time, like an outbreak of some disease is going to vanish before it becomes a problem. Most of these outbreaks don't become pandemics. And so the world of big pharma had ignored the coronaviruses, for instance. But yeah, I mean, starting in early January, I think we have an Australian to thank for hitting this, getting the sequence of the initial vaccine out. I don't know if you've heard of this guy, Eddie Holmes. He's a virologist at the University of Melbourne, and he had a collaboration with a scientist in China who got his hands on the first sample, one of the early samples of the unknown, of the basically a sample from the lung of a patient at the Wuhan Central Hospital. And this Chinese collaborator of his, this guy named Dr. Zhang, was kind of a Chinese patriot. I mean, he believed in his country, et cetera, et cetera. And when, there was kind of this clampdown, the scientists were being muzzled, they weren't allowed to share their data. And I describe in the book this scene when Dr. Zhang is on the phone with Eddie Holmes, and Holmes is like, listen, the scientific community's clamoring. We've got to release this sequence. It's getting to be ridiculous. And there on January 11th, Dr. Zhang agreed to share the sequence, and it ricocheted around the world, kind of starting the vaccine race.
Yeah. So that was with the original variant, I assume.
That was the original virus. Yep.
Yeah.
And that's what's currently in the vaccines. I mean, it was all based on this sequence that Eddie Holmes got out and shared.
Do you know much about how that works, as opposed to, now there's 32 different variants, I believe. And I assume the sequencing is different from each one, but I don't really know. How does that work as far as, the vaccinations and their efficacy?
Yeah, I mean, viruses evolve over time, and the coronavirus is a pretty big virus. I think it's got 30,000 nucleotide bases. The ACGT. Those are the letters of the genome that you may have seen before, and so there's 30,000 letters. Imagine. Every time this thing makes copies of itself, because that's what viruses do. They're just little machines to hijack our cells and make copies of themselves. There's sometimes little errors, like an old cassette tape. And so, yeah, so these viruses are mutating all the time. And we have seen several important variants emerge. I mean, the first major one at the beginning of this year was the beta variant. And the thing is, the vaccines that we use now, they just have one major protein, this famous spike protein. And that is what we develop antibodies against, because this spike protein is the way the coronavirus gets into our cells. And so the concern is about changes in the spike that are so large that the antibodies we developed against the vaccine won't work against a new new variant. But there, and there
is
are
that the case that it won't? Because I mean, like the flu shot, you used to have to get a different flu shot every year. For those who obviously decided to get a flu shot, which a lot of people obviously didn't. But you had to. It was different every year because it obviously changes every year, as far as I understand.
That's right. Yeah, I mean, there's sort of surveillance about and predictions about what's going to be the flu virus of 2022, and the vaccine makers will go and manufacture kind of a mix of various strains, and that becomes your annual flu vaccine. With the coronavirus, I think it's it's a little bit different. We're in this pandemic where things are sort of breaking out very rapidly, and we still don't know, because when your body naturally makes antibodies, develops antibodies to a protein to the spike, it makes one optimal antibody, but it makes sort of a range of them. And so there's some that might sort of, it's like you might have a key for an old lock, but it works on a few different locks. It's not perfect. And so sometimes you can have antibodies for one virus that will work kind of okay on the other. That's how the first ever vaccine is the smallpox vaccine. You may know, back from the late 1700s. And what was the smallpox? So smallpox was this horrible disease, killed like 1/3 of the people who got it. And it was periodically an epidemic in England and other places, or other places around the world. The famous Dr. Jenner, he realized that you could actually take a sample from a different virus, a related virus called the cowpox, which was basically, presents itself on the udders of cows as like kind of a pustule. And sometimes milkmaids back in the day would get it on their hands, creating these little pustules. Well, he saw that these milkmaids did not tend to catch smallpox. So by being exposed to one virus, a very, practically harmless virus, you were protected against another one. And that's because of this overlap in the antibodies. Yeah. And so, with these variants, it's kind of a similar story where, you could have a vaccine with one sequence, but it might protect you against slightly different variants. And the question is, how far can we go before we're going to be, the vaccines are no longer effective. The antibodies we make are no longer effective. And I think the dream down the road with the flu vaccine and the coronavirus vaccine is kind of having a universal vaccine or a pan-coronavirus vaccine that will guarantee broad immunity. But that's still a pipe dream.
Yeah. When you say broad immunity, what does immunity mean? Like, does that mean you're not fully immune to the virus at all, because you can still get it? So is there a possibility we can ever have 100% immunity to the vaccine, to the virus, sorry?
Well, that there's this term that people used to use, and they still do. It's just sterilizing immunity, like the polio vaccine, right? We've seen, that was such a medical miracle. I mean, nobody gets polio when you get a vaccine. It's practically nil, 0.00001%. But people, if you exposed a person who'd been vaccinated to the virus, there might be like just a tiny little bit amount of the virus in the person. There might be a tiny little bit of replication, but not very much. It's almost 100% effective. I think that's kind of one extreme. But I mean, even a vaccine that's 70% effective is considered extremely good. And it can, and especially in a pandemic context, it can cut down on the impact. And again, a person can be infected, but taking the vaccine, and we've seen this with the coronavirus vaccines, reduces your risk of hospitalization and death, even if the virus replicates in you. Because part of the impact, I think what's really important to know is part of the impact of the coronavirus or of a new disease that you've never been exposed to is that your body doesn't really know how to respond. And what's happened, what people have seen in patients is it's kind of the virus itself is not the thing that's so deadly. It's your body's, overreaction to it. It's your body. It's all of the grenades your body detonates to try to get rid of this infection when it doesn't have the right strategy. And a vaccine just helps you hone that strategy. It just gives you a little, something to train your body with. It gives you this harmless piece of the virus, so that you'll be prepared for the real attack.
Yeah. I wonder, I understand, from the first variant to now the 32nd, whatever it is, slowly, and I don't know if you've seen science of this, but because that variant changes, does that mean the efficacy of the original vaccine that we're still asking people to have, or the boosters even, wouldn't the efficacy just lessen as each variant comes out? Because surely that's the idea of the virus, to mutate. Therefore, our original vaccine wouldn't be as effective for later variants as opposed to the first one.
Yeah, that's one way that things can go. So, I mean, I think the story with vaccines is a little bit different than, let's say, antibiotic resistance, which you may have heard of as being a problem, with people who take antibiotics to fight a bacteria. Bacteria you're directly affecting their evolution in that way. I think with the vaccine story, it's a little bit less direct. Viruses are evolving in lots of different ways. Sometimes it's to, so they're not actually, because the virus is not responding to like a single chemical. Your body your body's immune system has lots of different tools. And so maybe, the some of the tools don't work as well, but other tools work fine. So you have your antibodies, but you've got the cellular immunity, which is, what we call the killer T cells, which can be very effective. And so I think the story with viruses is a little bit more complex. There's not there is the possibility with every variant that the virus is going to be less effective. And I think, but I don't think that's guaranteed. The virus can also be evolving in other ways as well.
Yeah, but I mean, again, is there any updates to the vaccines? Do we have the sequencing for the Delta variant, for example, that's been put into the current vaccines? Do we have the sequencing for the new Omicron variant that's been putting into vaccines? Is there any science or research or talk about that happening? Or are we still just pushing the original?
No, I mean, both Moderna and Pfizer have stated that they're getting the prototype vaccines for the Omicron variant, so that they'll potentially be able to manufacture it by like March, April of next year. The question is whether or not you really need that new design. Has Omicron, to what degree has Omicron evaded the immunity generated by the vaccine? The early data suggests that the vaccines are slightly less effective. But
I'd want the latest updates, and I think most people would.
I think there's kind of a question of, if you could have it tomorrow, that'd be great. But if you have to wait till March or April, that's different, because again, when somebody gets a booster shot, for instance, they are producing a diverse array of antibodies. They're not just producing one antibody against the coronavirus, and some of these still attach properly to the new variant. Some of them don't. So the vaccine might be a little bit less effective. You might end up producing useless antibodies. But the vaccine has not been rendered totally ineffective. I think the booster shot debate has been really an interesting one in my view. And I think there are questions about what is the right strategy, Lee, and I can't answer that, because that for some people, if you're sort of at higher risk, you certainly should be getting that booster shot, that third shot, to up your neutralizing antibodies. I think for other people, it's a little bit more of a gray area about whether you might be better in the long run waiting a little bit longer.
Right. Because what they're saying here, at least, is that we need to have booster shots every 6 months. At least that's what I'm hearing myself, and I could be wrong with that. And I think that's just about to start rolling out, and I'm hearing in the news too that the booster shots actually help boost efficacy of the vaccines and help people build stronger immunities. Now, is that scientifically shown yet? I mean, is there enough evidence there to show that?
Yeah, I mean, there is, I don't think that data are in about just how successful these booster shots are going to be with Omicron. I mean, there's been some incredible science done, but you don't get the answer tomorrow. I mean, we just learned about Omicron, 2 to 3 weeks ago. And, and I think researchers are still trying to figure out what the efficacy was and figure out how, the immune system is incredibly complicated.
Well, absolutely. But this is the question. Like, now we're talking about bringing out vaccines for 5-year-olds and above. But there's also this fear mongering in the media about this new variant. So as a parent, how do you then go, okay, well, this vaccine for the kids, which I assume is based on the past or original sequencing, not the new variant. How do we justify that? And I don't know if anyone's talking about the long-term effects, because I understand they've pushed this through very rapidly, this vaccination. Now, you've done some research into that about how they actually were able to produce a vaccine in such record times, because typically it was like 10 years, etc. But this one was produced in a lot less time. Is that right?
Yeah, I mean, the record here in the US was the mumps vaccine in 4 years. And yeah, vaccines typically take several years to develop. I mean,
and to be tested too.
and to be tested. But I don't, there were not any corners cut in the testing process. I mean, the thing about this vaccine is that we had a design for the vaccine and a strategy for the vaccine two
Yep.
days after that sequence came online. And the process, I mean, part of the reason that vaccines are slow to develop, honestly, is the pharmaceutical companies don't want to take the financial risk. So they do one little study, they sit back, they analyze it, they do their cost benefit analysis, and then finally they get to the end of the line, and then they have to start ramping up manufacturing. What we did in the States was we had Operation Warp Speed, where we started funding all of this manufacturing, before the vaccines had proven effective. And we
Yeah.
had a lot of different ways to sort of cut the dead space in the development of the vaccines. And basically running a lot of these types of experiments in parallel and things like that. I don't think that Lee, if you want to talk about the initial vaccines, I don't think that there's an issue with the safety of them. And I think the efficacy was pretty amazing. I think that the questions that I have, and
Yeah.
if I wanted to point to the touchy subject, where it's kind of, where I think many people, scientists included, have right to be skeptical of the motivations of the pharmaceutical companies, is what's going to happen with these booster shots. And like you say, wait, are we going to have to get shots every 6 months? Because that would be pretty lame. That's not the way a vaccine's supposed to work.
Well,
And
there you go. And that's again what I
right,
go back to. It's the original
right.
argument about trust and confusion in the public. That
Mhm.
creates a heck of a lot of confusion and doubt as to, the why should we take a vaccine if that's the case, and why should then we get boosters? Like it doesn't sort of make sense. And talk to us about the pharma companies. I mean, they've made billions of dollars out of this vaccine.
That's right. I mean, before this pandemic, vaccines were kind of thought of as kind of a loser category, and pharmaceutical companies weren't running to cash in on the coronavirus. I want to be clear about this. I write in the book, back in late January at the Davos meetings in Switzerland, Sanofi and Merck, two of these major vaccine makers, basically didn't want to talk about the coronavirus. They were focused on their flu vaccines. Pfizer told its partner, "Oh, we're not going to get, we don't want to work on this right now," because typically these types of vaccines, they outbreaks, they vanish before you have anybody to sell the product to. So when getting the companies involved and getting the might of the pharmaceutical industry to be making these vaccines was a really important coup. And in the end, the vaccine makers have profited immensely. And I think everybody rightfully should be asking questions about, considering a lot of the investment into the mRNA and into the design of these vaccines came from university laboratories. We have the National Institutes of Health here that have supported that. We want to see scientists want to see those funds, at least some of them, getting filtered back to help us defend against whatever the next disease is, because it could be even worse than the coronavirus, God forbid. But
are they being filtered back? Because you raise a really good point there. I mean, if the government's agenda is all about keeping public health, about the public health issue, then shouldn't the government just be providing this and not sending all the profits to a company like Pfizer or Moderna?
Well, I mean, are you a capitalist? Or I think there's so many benefits. We've seen that governments are good at some things and they're not good at other things. That's kind of why, and you have to make there is, I believe that sort of the capitalist system works in some respects. And companies have the thing is, the companies have a profit motive. Pfizer's a publicly traded company. It needs to keep its shareholders happy, and we've accepted that. And the beauty of it is they can put this kind of muscle, and they prove just how fast they can ramp up their manufacturing and deliver a vaccine, and that's amazing. But the government has its obligation is not to shareholders. Its obligation is to people of the country to make sure these vaccines are safe, to make sure that we are not getting taken advantage of. And so, yeah, I think there is a tug of war here, and I write a lot about that in the book, because Operation Warp Speed was just this a public-private partnership. And it was like, how do you get that, how do you get the might of industry, but not let industry take advantage of the nation?
And do you feel that the industry is taking advantage now?
I think that they are benefiting, and I think I think there's a couple issues where I would like to see a stronger approach from the Biden administration. I mean, we've had this big issue around the global rollout of vaccines and getting these companies to be getting them to places like nations where there's been really low vaccination coverage in Africa. Haiti, here in the Western Hemisphere, it's like 2% vaccination. I mean, these places are places where the variants are going to be emerging, is among the unvaccinated.
Yeah. Interesting. So booster shots potentially happening now. Hopefully updated vaccines with the new sequencings coming out as well. That'd be obviously a good thing. What are some of the the myths out there that you dispel in your book? Maybe some of the most common myths.
Yeah, I mean, I think one of the main things is I lay out sort of the process by which vaccines are tested. These vaccines were tested, kind of this push and pull between the threat of the pandemic and the need to ensure that the vaccines were safe. That was kind of a constant struggle among the folks in the government who were working on these efforts.
Can you explain how they were tested? Do you know?
Yeah, I mean the standard process is we had kind of the main trials is you start off, you begin with animal testing, sort of proving that the vaccine is immunogenic. That means that in mice, it's producing the right antibodies that can stop the coronavirus from getting into cells. And so that was kind of the first step before clinical trial would begin, before the first humans get injected with the vaccine. And so, I mean, that you want to prove that this thing has the potential to be effective, and then that it's not going to be acutely toxic. And then that's when sort of, the folks volunteered for the first human trials, and with the testing in the animals, how long did those tests run for before they were comfortable to pass it to humans? Well, I mean, with the Moderna vaccine, I can talk about that a little bit. They had sort of some background with, there's like sort of toxicology studies, which are really basic things that you do just to understand where, when you give somebody a medication or a vaccine, where it ends up in the body, understand how it affects different tissues. And so Moderna had some basic toxicology data that they had already collected for their mRNA vaccines, and they added to with these. But then before the clinical trials, there was basically 2 weeks. It was fast, basically.
It doesn't sound like a long time.
Well, nobody wanted to wait. I mean, this was February. No. And I think I have the timeline in my book. I think around February 4th, the National Institutes of Health received the first doses of the vaccine, and that they gave to mice. And then it was around like February 19th that they got, it was the day that they got the data that demonstrated that the vaccine produced antibodies. And that's when they said, all right, we can start testing this in people. So they began this with what we call the sentinels. These are the first brave folks who get the vaccine. I think they started with 4 people who got the lowest dose of the vaccine, and then they slowly ramp up, in this early phase 1 trial up to the higher doses. And it was at the highest dose, 250 milligrams. There were some pretty serious reactions. I described one guy who gets this fever and a throbbing head and just feels like crap. And so Moderna ends up dropping that high dose. And so over
how high was that dose, did you say?
200. So the lowest dose was 25 micrograms. The highest dose was 250 micrograms.
Right. Okay.
The idea is you want the lowest dose possible that still produces the right level of immune response.
Yeah.
And so, sort of that's the early stages of testing is just, okay, what's the right dose? Is this thing safe? And after a couple months, they'd sort of honed in on, the optimal dose somewhere between 150 micrograms. And that's when the big phase 3 clinical trials began. And this is what you need to test whether a vaccine is actually effective. That's the primary goal of these trials. You're also, and with the COVID vaccines, this was a 30,000 person clinical trial, which is much larger than a typical clinical trial. I mean, this was an enormous logistical effort.
Yeah.
And the idea with these trials is to compare how frequently a person who's vaccinated got COVID versus a person who's unvaccinated. So people get vaccinated and then they go about their daily lives and maybe they're going to naturally be exposed to COVID that's spreading in the community. And so that process was what happened in the fall of 2020 as we were all waiting to find out what the clinical trial results would be.
Yeah. Yeah.
And so, I mean, those large trials, they were designed to identify efficacy, but they also, because you're exposing many more people to the vaccine, you're also monitoring for any safety events and so on. But the rarest vaccine safety events can't be, like Guillain-Barré, this autoimmune disorder. That's like 1 in 100,000 people with, at the greatest. So, I mean, that's still incredibly rare. It's not necessarily going to get picked up in a large clinical trial, but it's something that gets picked up in kind of like post-vaccine surveillance and so on. But yeah, so that's kind of the process by which these things were tested.
Yeah. And what are they doing about, long term? I mean, there doesn't seem to be much talk about the long term issues or side effects that could occur from taking this vaccine and also, booster shots potentially for a longer period of time. How do they monitor or assess the risk of that?
Well, I mean, one of the things, the big challenge is the question here in the US was how much follow-up? How long do you want to follow a person who received the vaccine to ensure that there's no safety problems? And now this was kind of like the debate around the emergency authorization of the vaccine. Normally the vaccines, historically vaccines, would, take 6 months, maybe even a couple of years of follow-up of people. Yeah. In this case, the FDA came to a decision that they were going to allow an emergency authorization of a vaccine if at least half the people in the trial had over 42 days, had the vaccine for over 42 days. And the reason for this is when they reviewed, their historic vaccine trials, there is pretty much, any time that there is a serious side effect, it happens in those first 4 to 6 weeks.
Yeah, most of the people that I know that have had what I'd consider fairly severe side effects from it, it happens fairly straight away, within the first week, really.
Mm-hmm. Well, I mean, there's the reaction that somebody has to a vaccine, which is kind of your immune system ramping up. Whether or not something's really an adverse event, takes a certain level of investigation and so on. Yeah.
And yeah, I guess you have to sort of, if you've had that side reaction, you've got to report it and investigate it. Because I don't know if they're investigating it. If someone does have an adverse effect, other than just saying, well, it's all good, you've got no issues, just proceed as normal. But the long term, I always question the long term, and it's has the mRNA vaccine or mRNA, what do you call it, the process, the vaccine, has it ever been used on any other thing other than the virus? Is this the first time we've used it?
This is this was a groundbreaking thing. That was the first time that the mRNA has succeeded as a vaccine. It had been a dream for a while because, look at this company Novavax, which has a sort of the old school vaccine, the protein-based vaccine. That company, it's taken them forever to iron out their process and so on. mRNA is kind of like plug and play. And
But then you look at the
what you're getting at
mRNA. Well, you're looking at, number one, it's a new way to deliver vaccines, and number two, it's a new vaccine. So you've got two things that have limited time to be trialed and understood the potential longer term effects of these things.
I don't think there's any reason to believe that there would be long-term effects of these. I mean, the
Why is
mRNA. So, I mean, mRNA is a very short-lived molecule compared to DNA, compared to anything else. I mean, mRNA breaks down within days of being injected, so there's no trace of it. So the whole idea that it manipulates your genes is a myth, isn't it? Yeah, no, that's that's not true. I mean, I think that it takes advantage of machinery in your cells to produce a protein that your body can launch an immune response to. I mean, I think, I don't want to lead people down the wrong path, but the only thing we see with kind of the flu vaccines, this was interesting and news to me, was, flu vaccines, many people get them every year. Well, as you get older, you tend to be less, older people are less stimulated by flu vaccines because they've been exposed to it so many times. And so they end up having to take larger and larger doses. So there are there's some level
which
of
makes sense. Tolerance,
habituation. Yeah. And I think, I mean, we're a long way off from that, from COVID. And I think ultimately people not being immunologically naive to COVID is the most important thing at this stage. We're not talking, I mean, the scientific studies that show that people adapt to the vaccines is people who've gotten, who are regularly getting flu vaccines for 30 years.
Is that roughly how long the flu vaccines have been around for?
Yeah. I mean, the flu vaccines were like, the 70s and 80s is when they
70s and 80s, was it? Yeah.
But I mean, I don't know.
So, we've had many years now of obviously flu vaccines, and I don't know the science of the outcomes of long-term usage of it, other than what you've just said. I guess the tolerance makes sense. So you'd assume that the new mRNA vaccines, well, you'd hope anyway, that they will play out much the same as previous vaccines were used.
Yeah, I don't think that there's any reason to think that they would be different. Well, they are different. They are. It's a delivery mechanism.
Yeah.
I mean, whether you're delivering it as mRNA or the virus vector, or the protein, it's all exposing your body to, ultimately the main thing is to this protein.
Yeah.
The coronavirus spike.
Really interesting, eh? Mate, I know you've got a lot of more research and science, etc., in the book, much more than what we've gone into today. And I really appreciate you coming on and sharing, because I think it's these discussions that need to be had to at least give people the opportunity to explore for themselves the information, So for that, I thank you. Thanks for coming on. Appreciate it, Brendan.
Yeah, good to talk to you too, Lee.
I'll stick the book link in the show notes. Is there a way people can reach out to you, Brendan, or just best to get the book? How do you like?
I've got a website for the book called thefirstShots.com. Go check that out, and there's a box down below that can send me messages.
Cool. I'll stick that in the links. So you guys check it all out at thehiddenwhy.com. Until next time, peace, passion, and purpose. See you soon. Thanks, guys, for listening to this episode. I hope you enjoyed what you heard. I hope you love what you're hearing. If you like this episode, guys, or any of the episodes that you're listening to here at The Hidden Why, please do me a favor by sharing it. You can share it with your families, you can share it with your loved ones. You can do that by using your favorite social media channels, using the icons on the platform that you're listening to The Hidden Why podcast. Also, guys, if you're a fan of the show, please connect with me. Connect with me at thehiddenwhy.com. I love to hear from you. I love to converse with the people that listen to this show to find out what they enjoy, what they don't enjoy, and perhaps if they have any questions or feedback for the show as well. You can stay up to date with all that I'm releasing here, guys. I do a solo show every Monday, a 3-minute thought every Thursday. I do 2 interviews a week on a Wednesday and a Saturday, and a book review every Friday. You can stay up to date with all that by subscribing to my newsletter at thehiddenwhy.com. Just enter your email address there, and also subscribing to the podcast on the platform that you choose to listen to your podcast. You can also support the show, guys, by using the Amazon links at thehiddenwhy.com. So if you like books, you can get all the books that I review there, and anything else really that you like to purchase through Amazon. So use that link, it helps support the show. And we've also got a deal with Audible, guys. Audible is a fantastic way to listen to all your favorite books. We've got a deal with them, so you can get 2 free books when you subscribe subscribe to a 30-day free trial. So check that out again at thehiddenwhy.com. Guys, that's it from me. You know what to do. Go out there, breathe more passion into every single moment. Do everything with greater purpose, and in doing so, you will discover your hidden why. This is The Hidden Why. My name is Lee Martinuzzi. Until next time, peace, passion, and purpose. See you soon.